basic identities. And you have to write these notes. I'll try to get caught up next week, but I'm behind right now. Way behind. If y'all talk the whole time, y'all not going to be able to hear me. Now, if you go back and watch this video, you have a pause, fast forward, and all those buttons. You just have to get through all the junk and get to the product you need to see again. Yeah, this is junk. I'm just recording right now, everything we say, and it's recording the screen. Okay, so when you look at the video, you're going to be able to see this, and hear me, and audio. Okay? Okay. Alright, here we go. So, let's start with reviewing what an identity is. An identity is an equation that satisfies every number for which it is defined. So remember that sometimes they give you equations and they say that this is for all integers, or this is for all real numbers, or this is for everything but zero, right? That's the definition of which is defined. So if they give you an equation and say this is, and they don't really define anything like it can't be zero or whatever, then that means they're not defining it for everything. So it's an identity is the equation that's true for everything it's defined for. There are an infinite number of true identities. I couldn't even give them all to you. There's an infinite number. But there are some that are very common that should be memorized. Excuse me. So let's start with the most basic ones that we've already talked about. Let's talk about the reciprocal identities. Alright, these are basically the definition of your trick functions that you already know. So, the first one, these equations are identities. Sine of x is equal to 1 over cosecant of x, because they're reciprocals, right? If you put a value in for x here, and you put the same value in here, these two sides will be they're reciprocal of each other. Another reciprocal you learned was cosine of x was the reciprocal of cosine. Was over secant. You already know the identities. Third one is tangent. And that's 1 over cotangent of x. And then they go the other way as well. If I gave you cosecant of x, that would be 1 over sine. So there's some elementary direction. Alright? Everybody okay with those? So basically, because they're identities, if you were solving an equation and there was a secant in it, and you needed there to be a cosine in it, you could take the secant out and put this in with each other. So that's common. You're going to use these identities to do a whole lot of substitution and problem. Okay. Alright, the tangent, there's two tangent and cotangent identities. You need to make sure you know. We've talked about them already. They came up when we did the unit circle. We've already seen them before. The first one is that tangent can be written in terms of sine and cosine. And it makes a fraction in sine of x over cosine of x. Remember that? We did it when we did a circle yesterday. Cotangent means the opposite of that, because it's reciprocal. It was cosine of x over sine of x. So learn those two. Make sure you know them. Maybe Anybody get approved if those are true? Because I already did once. way back in section 2:1. I think it was in 2:1. Maybe we moved in. Okay, we've had some other identities come up, and we're going to expand on them. These are the Pythagorean identities. Okay, the first one is the one we've already worked with a little bit. Yep. Alright, here's the first Pythagorean theorem. I think we already learned. Sine squared x plus cosine squared of x is equal to 1. Remember that one? What section was that in? 1 something, 1.6. Somewhere back there. It was when we learned the reference angles. Yeah, that's the one that he didn't put on the test because he was going to come back later. Alright, so we've worked with this one a little bit. We can take this a little further. And we get two more identities. The second one is that 1 plus cotangent squared equals cosecant squared. Let me show you how we get there. One of the big rules of math is you can't use any anything there until it's clear to you. And so the college level math, if you were to major in math, you do a lot of times your professional So if I were to start with this one, which we've already learned, right? We already know this one's true by the Pythagorean theorem. Alright, if I were to divide everything by the sine, by sine squared x, I'm allowed to do that, right? In an equation, as long as I do it on both sides, okay, so what I'm going to do is I'm going to divide this side by sine squared of x, and I'm going to divide this side by sine squared of x. On this left side, I'm actually going to break this up. I'm going to make this two separate fractions. So this is sine squared of x over sine squared of x plus cosine squared of x over sine squared of x. You know, you just break the two. Everybody following me? What I've done? I'm following just a regular algebra. Y'all been using it forever. What is sine squared over sine squared equal to? 1. What is cosine over sine equal to? And because it's squared, this is cotangent squared of x. And 1 over sine is a reciprocal of what? Cosecant. Cosecant. And it is squared as well. So I just proved to you that we can get from one we already knew was true to the second one that I told you to learn. Everybody following? Okay, so this one you need to learn, that's the second one. And the third Pythagorean identity is tangent squared of x plus 1. Awesome. I give it my then. Thank you. Alright, tangent squared of x plus 1 equals secant squared of x. And this one's going to work pretty much the same way. So let's see if y'all can tell me what to do to get there. Same idea as number 2. So if we start with the one that we knew, which was sine squared of x plus cosine squared of x equals 1. What should I divide it by to get to tangent and 1 and secant? Divide each cosine, so I'm going to divide everything by cosine. And these are the kind of things you're going to have to be able to see on your own as you go through this math, because you're going to be trying to get from one thing to the other. So sine over cosine is equal to tangent. Cosine over cosine is 1. 1 over cosine is secant. So we got from those two to the 1. Okay, so you need to I do use to simplify, which is one of the ways that you use them. So we're going to use them to simplify your textbook rewrites using editing to simplify. Alright, our directions here are to write each expression in terms of sine or cosine. Simplify. So they don't want any cosecants, they don't want any secants, they don't want any tangents, just sine or cosine. Simplify. Here's our first check. Alright, the first one, tangent of x. Alright, so we're going to write in terms of sine, cosine. So if y'all think back to your how can I write tangent in terms of sine, cosine? Sine over cosine, so tangent. I'm going to write that as sine of x over cosine of x. Over. How do I write secant in terms of sine of cosine? 1 over cosine. And then I need to simplify this. Tricks don't be something here. It's just algebra. We're not graphing and all that stuff. This is just algebra. Y'all, we learned last semester how to deal with expressions. There's dividing, right? So I'm going to write it out this time. Some of y'all I don't have to, but if I were to write it out as sine of x over cosine of x instead of a fraction, you can write divided by 1 over cosine. What am I going to have to do there? Alright, I'm going to have to multiply with the second, so I have sine of x over cosine of x times, I'm going to flip this one upside down. What happens to this cosine? What else? It's just algebra. You put it in terms of sine and cosine, and you simplify this first using your algebra skills. So this should make y'all feel a whole lot better compared to what y'all were doing. A lot of it, yeah. Everybody, I'll probably do the video. Alright, B. Sine of x plus cotangent times cosine. And if they put them side by side like that, it means they're multiplying. Sometimes they put parentheses around them. Sometimes they just put them side by side. Okay. So our corrections were put everything in terms of sine and cosine and simplify. So which one needs to be changed? The cotangent. Here, it's not in terms of sine and cosine, so we're going to replace it. So we have sine of x plus, how can I write cotangent in terms of sine and cosine? Cosine over sine. I'm going to put a time symbol here just so that they're broken up a little bit. Yep, I'm going from there. Make sure I answer it. Yes, this could be also cosecant. If your math Excel doesn't take it, then turn it back to cosecant. The directions they put in sine or cosine and simplify. Completely simplify would be you did leave it as a fraction, but you turn it back to. Is everybody following? What? Y'all try this one. See how far you get. They can't get long, but it's just algebra. Tangent of x, cosecant of x, all over secant of x. Put it in terms of sine and cosine and simplify. What y'all put in for tangent? Y'all still thinking. What'd you put in for cosecant? What'd you put in for secant? Y'all get that? Everybody? Y'all get that step? Hey, what happens to these two signs on the top? Cancel this on the top with a lot of what you get. 1 over cosine over 1 over cosine. How do I write that? Right, 1 over cosine divided by 1 over cosine. I have to put it 1 over cosine of x times cosine of x over 1. They cancel, which means the answer is very good. let's go over here and think about what we know about the tangent function. What is tangent equal to? Sine over cosine. We know that. This is the tangent function in terms of sine and cosine. We want it just in terms of sine, which means we want to get this cosine out of here and replace it with something equal, but that has sine in it. Okay? It's really not that complicated. If you will think to that other idea that I told you use all the time, this one, sine square of x plus cosine square of x equals 1. This identity will help us get rid of that cosine. Here's what we're going to do. We're going to take this identity and we're going to solve it for cosine. Whatever we get, we're going to plug it in right there. We solve this for cosine, that means we're going to get over here sine and number 1. That's what I'm saying. So, and then we're going to take that cosine out and replace it. So let's do that down there. So to get rid, solve for cosine, we're going to subtract sine squared of x both sides. That's plus cosine squared of x equals 1 minus sine squared of x. But I don't need cosine squared, I need just cosine. How do you get rid of that square? Both sides. So cosine of x is equal to, now when you take the square root, so you get plus or minus, right? The square root of sine squared of x being equal to that. Following. Now I have cosine equal to the only thing over here is sine is the whole. So what I'm going to do is I'm going to take this out. I'm going to plug that in. So I'm going to get tangent of x equals, copy this down up here, sine of x over, instead of cosine, I'm going to put in this plus or minus square root of 1 minus sine squared of x. That's your answer. So we get tangent in terms of sine. That's right from the bottom of this. Because they just ask you to get tangent in terms of that means. That's it. And it has a fraction of denominator as well. I knew the tangent was sine over cosine. So I used a different identity that had sine and cosine in it, and I solved it so that I could take cosine out and put something with sine. So I used this identity that had sine and cosine in it to solve for cosine. And then I was able to take that out and put the okay. Now, if you put this in the math example, guys, but you're probably going to have to put in plus or minus first, and then put in that fraction box, and then put in your sign on the top and your stuff on the bottom. Don't put that plus or minus down here like the tangent. Put it in the middle before you go. Alright. Any questions on that one? That's the only example that we have. I can probably have another one if you want. Alright, example 3, and this is the last one we're going to do in class today. I'll put the other stuff on. You can take identities to find function values. Now, he has said that this example 3 is on the next test. Or that's what this list is going to be. Okay. Y'all ready? This is pretty much what you're going to do. Y'all know how we just found all these different function values, make the 30 degrees, cosine 30 you can start to do a lot of this, right? So what if we got an agreement that does not fall as of right now, y'all don't have a whole lot y'all can do with it, right? But you can use the activities that we've got to help you find it. So here's an example. You ready? All right. Given that alpha is equal to negative 2/3, sorry, not alpha, it's negative alpha. The event of some degree measure is equal to negative 2/3. And alpha is in quadrant 4. Find the values of the remaining 5. So they ask, they want to know what is sine of alpha, what is cosine of alpha, what is secant. What is cosecant? What is cotangent? Alright, the catch here is you don't know what the degree measure is. All you know is what tangent is. Agree? So, Carl's right, some of it's easy, some of it's not. We are going to use our trig activities to find all these. And it really doesn't matter what order you do the activities in, it's just that it's just not going to be fun. Okay? Okay, so here we go. Alright, they gave me tangent. I'm going to use that diagram identity that looks like this. Secant squared of x. So we have alpha is equal to 1 plus tangent squared of alpha. But that identity we just did a few minutes ago. Alright, using this identity and what I know, I can find secant here. Secant is equal to 1 plus, what's our tangent? Negative 2/3, so I can take out tangent and replace it with negative 2/3. But it's going to be squared because it's a squared. What is negative 2/3 squared? Over 9. And I can add that up because I can rewrite 1 as 9 over 9. That gives me 39. But I have to take this square root there, which is going to give me what? Okay, plus or minus square root of 3. Okay, why did I say plus or minus? Because when you take a square root and get plus or minus, it's going to be either or. How do you know which one it is? Anybody? All students take calculus. What quadrant do they tell us we're in? The fourth. What is positive in the fourth quadrant? Fourth quadrant? Cosine and what? Don't listen, please. Cosine and its reciprocal. What is the reciprocal of cosine? Secant. These are positive, so my answer is going to be what? Positive square root of 3. There's secant. Alright, now we can do what Carl said just a second ago. We can do the reciprocal. So we know that tangent is equal to negative 2/3, right? Cotangent is the reciprocal of that, so put that down when you get negative 3/2. It stays negative because the only thing constant in the quadrant is cosine.
ration is happened to student services. Ration is happened to student services, please.
Almost at the end of the week. But Tangent Coach and Jennifer said that each other. Remember, Tangent is equal to 1 over cotangent of reciprocal. So they told us the problem. It's tangent negative 2/3, so don't cotangent with it. I'm coming back. We can do the same thing with secant. What is secant the reciprocal of? Cosine. So I can flip it upside down and do what's it. 3 over the square root of. Can I leave it like that? Right. But 3 square root of 13 over 13. Is it positive or negative? Why? So now there's cosine. And use the identities to find the sign. Remember, you're using the identities here. I'm not going any further, so I'm going to use cosine squared. Which one of these do I know? I know cosine. So I have sine squared alpha plus 1 times 3 square root of 13. I need to square that. 1. Okay. So y'all are here. Okay, so I need to solve this. So I'm going to subtract this from both sides. So I have sine squared of alpha minus. Square it down, square it down, subtract it again. And if I square this, what's 3 times 3? 9. This is square 13. Square 13. 13 over. So it should come out to be 1 minus, I think, 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. 11. all students, they must sign positive or negative. There's keep it up. Alright, co-secant is the reciprocal. Right? Cosine. So like flip it upside down and simplify, so cosecant. I flipped this one upside down. So it's negative 13 cos 13 is 13. I've worked it out. I've got it. I got to rationalize the denominator here. This is going to give you negative 13 square root of 13 over 2 times 13 is 13 cancel. Get negative square root of 32 equals to this one. Okay, so your first, you're going to see if you got that tangent to say, oh, that negative 2 is 9. Oh, that 3 is. Goes on. It starts sticking through your hands. They tell you to use this if you have used it, and you get it to one. Once you get one, then you know the second four, you can flip it, which that's the negative, reciprocate it, and solve it. Okay? All the time in Excel, how do you do that? You go, you just assign rows, and you assign for all the rest, and he assigns you all the odd. So I'm going to upload that video so you can watch it and you can do this section. But this is what the same substance. Okay? Y'all can work with mathematics and until the bell rings.